So the next calculation we want to do is something like this. And this is called the standard deviation. And let's just look at it quickly. And then I'll just point you to this website. If you haven't studied it before, the Khan Academy is just great. I also have some videos I can show you. I can point you to my videos, but either way is okay. But anyway, let me just explain this a little bit first. So, first of all, what's this symbol? So it's the mean, right? We just finished calculating the mean. Okay? So, after you calculate that, which we know how to do, we can either do it the way we just did it by sort of here, when we did this, or we can just use this function. Either way, of course, you're going to probably just use that function. So after you do that, you want to subtract from each element of x that we have here. We're doing x up here. So from each element of x, you want to subtract, or no, this is x plus c, but anyway, from each element of x, you want to subtract the mean. Okay? So that's going to be an example of recycling, right? Let's just try that first. And then I'll come back and explain this formula in more detail. So here's x, right? I just did x. And now I'm going to do mean of x, just to repeat it again. Now you can see that the mean of x is a single number. So what happens if I do this? Isn't this an example of recycling? Well, let's just do it very simply. Suppose before I do it that way, suppose I did x minus 10. Okay, so this is an example of recycling, right? Because what sorry, I need to explain that this is an example of recycling. Because even though we write 10 here, R actually thinks of this as a vector of length 1. Okay, that's kind of weird. Let me write that down. Okay, so let's consider this. So even single numbers are considered vectors by R. Okay, so that sounds a little strange, but so the number 10 is considered a vector of length 1. So maybe that doesn't always mean anything. Doesn't always have consequences. Sometimes this is not important, but sometimes it does have consequences. So for example, if we do x plus 10, where x is a vector, then just like in the case when we added a vector of length 2 to x, remember in a video, few videos ago, when I did this, I said this was x, and then I added y to it, where y was a vector of length 2. Remember, it recycled 0 plus 1, 10 plus 2, 0 plus 3, and so on. So just in the same way, so just like in the case where we added a vector of length 2 to x, and it had to recycle, so now, since even the number 10 is considered a vector, so when we add that to x, where x is the longer vector, here too we are adding a vector, this time of length 1, to x, and so it will have to recycle. So what it means is that each element of x will have 10 added to it. Okay, so let's just try that. Okay, so before I specified that y, when I added y, where did I do that? Here, when I added y, I had specified that y was a vector, right? It was obvious. This is, where is it? Y is a vector. Right, here's y, or even the definition, y is a vector. So it was obvious that y is a vector. But still, even though it's not obvious that 10 is a vector, it is a vector. And so when we add a vector to x, it recycles. In this case, we just add 10 to 1, 10 to 2, 10 to 3, and so on. So when we do that, we get that. Okay? So adding a constant, this is usually called a constant, to a vector means that that constant gets recycled. So really, I shouldn't say it's a constant. I should say it's a vector. But either way, it doesn't matter. But anyway, it treats it like a vector of length 1. And of course, the same thing if I do x minus 10. X minus 10, still, it's going to treat it as a vector. So where was x? I don't know. Anyway, here's x. 1 minus 10 is negative 9, and so on. Okay? Okay. So now going back to this formula, what's going on here? So like this summation sign is kind of handled by this process of x adding things element by element. Well, I don't know if that makes sense or if that's clear, but let's see what's going on here. So what do we want to happen in this formula? Remember that x is like there are many different values for x. That's what we mean here. So there's x1, x2, x3, x4, x5. Just like we have over here. x1, this is x1, this is x2, this is x3, and so on. So we take the first value of x minus the mean of x. Remember, the mean of x is just a single number. In other words, a constant. So we take that, and this is just a single number. We take that minus this number, the mean, and then we square it. Then we square that whatever we got, and then we sum up all of them. So how can we do this in R? So the question relates to R treats things and numbers as vectors, and we can do vector subtraction in this case. And how can we arrange the vector subtraction so that we get this result? Of course, at the end we're going to divide by n minus 1. We want to get if we want to do this calculation. Now, why we want to do this calculation? It's called the standard deviation, and that's why I wanted to point you to, in case you don't know what this means, in case you don't know how to use this, or where it's used, or why we do this calculation. You can either look at, I'll just give it to you now, this. You can actually just do it. All I did was do a search for standard deviation in Khan Academy, and I get this. So you can do this, and you can go through this and then get down to here. Or if you want to, you can look at my videos. So you can go to this address, sentimentmining.net/S for statistics and V for videos / and you'll find this. And if you watch the second video, I talk about starting here at minute 2 minutes and 56 seconds. I start to talk about what you need to understand to understand the standard deviation. So if you want to look at that, you can look at that also. Anyway, so going back to this, how are we going to do this? Okay, so let's see. They call it, in statistics we usually read this as x bar. So let's just call it x bar. Let's create a variable which is the mean, and call it assign it to this variable x bar. Okay, that's just a simple renaming. So we have the mean stored in this variable called x bar. Now what do we want to do? I want to take each element of x and subtract the mean, subtract x bar from it. So how do I do that in R? I just do this, right? X minus x bar, right? That's going, x bar is a single number, but x is a vector. So, but we just saw how it's going to work. It's going to subtract x bar from each element of x. In fact, if you want to check it, you just do that. So you see that now we have each element of x has x bar subtracted from it. And then how do we want to square for each one. But remember, if I square this is a vector, right? X minus x bar is this vector. So this is vector. If I perform an operation on this, like squaring, it's going to square element by element, which is what I want. I want to square this thing. I want to take each element and square it. So I want to do this. Vector, yeah, I'll just do it like that. X minus x bar. And then how do we square? We do that, like that. And that's going to square each element, which is what we want. Okay, so if you understand the calculations involved, you should realize that that's what we want. Okay, now what do we want to do in this formula here? So we just did this part here. I should say we just did this part here. Okay, let me introduce another. Do you remember what y was? Another function called sum. Now, do you remember what y was? What was y? Y was 0, 10. Let me create another vector. Do I have z? No. Okay, let's create another vector. Let's try k. And let's say k equals c 1, 2, 3. So what's the sum of 1 plus 2 plus 3? So it's 6, right? So let's try that. Sum of k. So what is this going to do? Maybe you can see what it's going to do. It's going to give us 6. Okay, so that's the sum function. Now, suppose that I want to... So what do I want to do now? In this formula, I want to take all of these and sum them up here. So, what do? I just do, let's see, I'll just do that, that. I'm using the up arrow key because I didn't feel like typing it again. And then I just move over here and write sum and open bracket and move to the end and write that and get that. So now I've done this part. I've summed that stuff. Now let me introduce another function which is probably pretty simple. SQRT of 64. What is that? Do you think? The square root. The square root of 64 is 8. Okay, so that's another function. So what do we want to do? We want to take the square root of this thing divided by n minus 1. What is n? N is the length. So it's the length of the vector, length of x, minus 1. So let's write that part out first, and then do the square root. So I hit the up arrow twice, so I don't have to retype it. Divided by the length of x, right? So that's the part underneath the square root sign. So not including the square root sign yet. Is that right? Something looks wrong. I guess it's right. Yeah, that's right. Okay. And finally, what do we want to do? We want to take the square root of that. So I'll hit the up arrow key so I don't have to type it. I'll put a bracket here and a beginning, and I'll put square root here, SQRT here, and open like that. And then we have the full calculation for the standard deviation. Now, if you wanted to, you could have done SD like this instead, of course, just like that. Oops, sorry. I made a mistake, didn't I? I think. Yeah. Let's try that. Okay. I tried a bunch of things here. I had them all. I messed up the parentheses. And also, the main point was that I forgot to do length of x minus 1. Remember, that was in the formula for the standard deviation. And I forgot to do that, as you might have noticed. And also, if you check here, you'll see I messed up with parentheses. This is the right set of parentheses. If you check here and you work it out, you should see that this is the right set of parentheses. So finally, when I did that, I do get the same thing as here. Okay? So you should check that, make sure you agree. Okay? Now, by the way, when I forgot to do the length minus 1, sometimes we use that calculation without the length minus 1. And if you listen to Khan Academy and their discussion, they're going to discuss why the n minus 1 is there, and when you don't use it and when you do. But in general, I think we can say that we'll use the n minus 1. Anyway, and I've included that here. Okay, let me stop this video and come back with the next one.